Okay. Those who are joining us on the live stream, this is a internal design review meeting looking at incremental new features in Wolfram Language. Okay, so what is the point here? This is
a suggestion of having a version of string replace which is able to act only on a subset of the characters. So yeah, it's a way of limiting the area of action of the rules.
We don't have anything like that for ordinary replace.
Exactly. So in a sense, in general, limiting in an arbitrary expression would be more difficult. Here, the linearity of the string helps.
Yeah. Seems hard to justify doing something like this. I mean, it would seem to me that a more general thing, which we haven't thought about and haven't needed in 30 years, is something where you could say, of a rule, you could give, instead of a /semi, which is a content-related, this rule applies only when, A arrow B /semi, whatever. That's, okay, so that's a side effect thing. This would be restricting by content here. And there would be another thing, which is applies within or something like this. A arrow B, and then this gives some kind of criterion for a part number criterion. See what I'm saying?
Yes.
I mean, there's a similar kind of thing that we've wanted for map for a while, which is to be able to say map onto something with a restriction. I mean, so right now, the way that we're restricting map is purely by level number and so on, right? We could imagine some much more elaborate restriction.
Yes. So, for example, something that sometimes is needed is do not let replacement or mapping functions enter this area.
That's correct. But you want to be able to say that with the mapping function and not,
yes, it could be an option which specifies the heads that shouldn't be entered, for example.
Right. Right. That's a reasonable possibility. But I mean, here, this is a completely different thing. That's reflecting part numbers. That should not be, I don't know. This does not strike me as the most critical thing right now. This would be an interesting thing to study, this idea of the possibility of a function that describes its own domain of applicability within an expression.
Right. Yeah, that would be certainly useful. Either positionally or by some ignore something option that says do not enter here.
Right. Okay. All right, let's go on. I don't think that's not going to make it there. New property in nearest and take largest.
Yes, so this is something I suggested by imitating what entity value does, which is that it can reproduce the entity in the result by writing this property entity.
Yes.
So I find that quite useful because it avoids some threading a posteriori and things like that. So I wonder whether we should have something similar in nearest and take largest with a new property notation. Because you can in the lists of results, we can put back the original point.
By the way, somebody on the live stream is mentioning lenses from functional programming. Not quite sure what that is. And anybody here happen to know about those?
I don't know either.
Well, it's homework. We can go find that out.
We will.
Okay, so what are you suggesting here? So this is part of...
Yes, so in this nearest, which already works, what do we write in the list of properties that reproduces the default 0.6 in output?
I see what you're saying. Okay.
Because sometimes it's needed, and if we have a long list, then we have to do threading with the corresponding values.
No, I agree. I think it's useful. Okay, so we've got element, which is the element index, which is where that element is, distance. So what are you proposing here? So I see. So you're proposing something like source here, but that's
source or origin. But for example,
so what are the functions which this is relevant to?
So far, this will be nearest and take largest, and the family.
So right now, the special features are element index, distance.
Mm-hmm.
And what are they for take largest?
I think the same. Perhaps distance is not there. This has been recently added, so it's not even documented yet. So Danny, do you remember which ones? I think it's certainly index and element.
That's it.
Yeah, so we didn't add distance.
For take largest, yeah,
yes.
No.
It's not even documented yet.
No.
So that's a third argument. Wait a minute, what do we document here? That's a third argument for take largest?
No, it's list arrow properties, the same as nearest.
I see. That original list arrow properties.
Exactly.
So what is it that you'd be asking to reproduce in the take largest case? The n or what? In the nearest case, what you're asking to reproduce is the original value, is the target effectively.
Yes, sorry, I didn't think well enough. Yes, no, this doesn't apply to take largest.
Doesn't seem to.
Yeah.
So
take larger if we ever do that, maybe.
I mean, what about value for this to represent that thing?
It's going to get confused with element.
I think so.
I mean, I would actually have guessed the other way around. The element is the one you're giving as input to test against, and the values are the ones that are close. So we would be reversing that view.
Well, so wait a minute. So are you saying that then you would prefer input? That's not clear either, because they're both inputs.
Yes, right.
Etienne suggested query or query element. It's not
I don't like it. I think that's very specific to thinking of this as a, probing something with that. Okay, so let's just think again. How would we describe what this is? Nearest looks at a list of elements and finds the element that is nearest to a given value. That's the word we would use. There's a collection of elements, and we're asking what is nearest to a given value, I believe.
Yeah, I was looking at the documentation. We always call it X, so that avoids the...
There's always abscissa.
What? Abscissa? Sounds like some kind of, conqueror from the Middle Ages or something.
I think it was.
What, abscissa? You can't.
Yeah, with AE being the plural, it was this horde.
Right. Okay. I favor value here, but I would like to know whether there are any other functions which we're going to do this with. Doesn't nearest come in a family with some other ones that we did this with already?
No, so far this extended notation with properties is only nearest and take largest family. Yeah,
wait a minute. What's the take largest family? I
mean, take smallest, take
largest by.
Yeah, but why are they? What are these accessors? How do those appear in take largest?
Because in take largest, you are interested in getting the value and the position simultaneously.
I see. Okay, I favor calling this value. Okay, let's move on.
Okay.
Intermediate geodisplacement. Why do I think
Yes.
this is going to be a complicated story?
No, not so complicated. This is motivated by the work on geotrajectory. So the idea here is that given a geopath, we want to get the point which is like 40% through that geopath or something like that. So the suggestion I have here is that we create this new notation here, arrow Madrid, to represent the geopath from here to Madrid, or the displacement from here to the Madrid.
Okay, so wait a minute. What does geodisplacement have in it right now?
Geodisplacement right now takes either two arguments to compute that thing I'm having there, here at Madrid, or the container is at least this distance comma angle. So this is, as many other geofunctions, this is both a constructor and a container. So this.
Hold on.
Yeah.
So right now what this is doing is, if I say geodisplacement, so just so I understand, if I say geodisplacement here, for whatever it thinks here is, I don't even know where it thinks, I have no idea where it thinks I am. It probably thinks I'm in Illinois, but it would be wrong. Okay.
Yeah, so that's
I see. So that canonicalizes to a distance in meters.
Correct.
And a bearing.
Exactly.
Okay. So what are you proposing now?
Yes. So the idea is, it's clearer in the next geodisplacement input at the end of your page. So the idea is saying, in the geodisplacement from here to Madrid, give me the geodisplacement that would take me 2,000 miles. So it's a way of expressing intermediate points.
Right. But so you're saying geodisplacement starts.
It doesn't specify where it starts once it has canonicalized. So you can use it in other functions. There is the function geodestination. Geodestination takes the original point and the geodisplacement.
Sorry, I'm confused here. So a geodisplacement normally is in geodestination, you start at an initial point and then you go a particular geodisplacement is a generalization of go at a certain bearing. It's the polar coordinates version. Is that right?
Exactly. Yes, correct.
Okay.
Yes.
So, and the issue is, if you have specified two endpoints for the geodisplacement in this third form, right?
Yes.
You want to say, I don't really want to go that far. I want to go in that direction, but I don't want to go that far. Okay, so what you're proposing here is that this format could represent the angle. I see, that the angle could be represented by thing, arrow, thing.
Right.
And that then the distance stays the same, stays in the same place.
Exactly. And further down, we can also say scaled of 0.5, and it's half distance from here to Madrid.
Okay. It doesn't seem silly to me. Now, you're also proposing that there's a pure thing, which is the analog of lock 1, lock 2.
Exactly. For consistency only. But that's certainly not needed.
Yeah, well, I think it's okay. All right, this does seem reasonably sensible. I don't think I have a problem with this. What else is there to discuss about this?
No, nothing. I just wanted you to see it and approve it, and then we can use a scale or with a list, etc., so that we get many of those intermediate points, etc. Because Michael needs something like this to specify intermediate points in geotrajectories, etc. So
wait a minute. Scale with a list inside it. This is going to be a listable thing. So geodisplacement is going to be. Is that syntax?
Right now, that's accepted. So we can have a list both in the first argument or in the second argument, meaning displacements of these distances for this angle or for this. Actually, you can have lists in both.
But so it's a listability type thing where they either have to be, I mean, if they don't agree in length, it's going to give an error. Is that correct?
No. I mean, that's like geo position with a list of points. It represents a list of geo displacements. And that will represent
so
some
if
sort
I say 70, 80, 90, whatever it is here.
Yeah.
Right?
Yes. So that's like a matrix of geo displacements. And now you
so
can do.
Now, what am I going to do with this?
Just say geo destination here with that. And it gives you a matrix of geo positions.
So it's really the outer product thing. Right?
It's the outer product, exactly.
What happened?
Try geographics of point.
What happened there? That seems like a bug.
I think GeoListPlot is perhaps not prepared to handle geographics of point and that value.
Okay, but so there's a bug there with respect to GeoListPlot.
Yeah.
That's a Sushma issue too.
Mm-hmm. Yep.
Okay, so I see. So it's generating outer product always in this case. And so there's no listability threading. It's a pure outer product.
Yes, yes.
All right.
Mm-hmm.
Looks good to me. That was easy. Should we move on?
Yes. Okay. So this topic is a bit larger. So we are improving various things with order functions. So first of all, there is this issue we have discussed other times, I think, of the F versus P function. So F is the functions that we put in the second argument of sort by, and P is the function that we place in the second argument of sort. And first,
right.
I wanted to ask you about names.
Well, people often call these ordinal and cardinal, don't they? Sorting.
I don't think so. I haven't heard
I mean,
of
the
that.
Binary function, the P function is a binary function. The
Yes.
F function is a unary function.
Indeed, yeah.
So, I mean, I remember like from APL or something, there was this notion existed there. And I think the point is that maybe I'm wrong here, but you know, this idea that there's there are names for this in mathematics and elsewhere, I believe. Who knows them?
So with respect to the P function, I think the correct name is order function. We call it ordering function typically, which is close.
Yeah.
But the main issue I see is that order, capital order, is an order function, but ordering is not an ordering function. That's the thing that I find a bit confusing.
Sorry, say that again.
Yes. So we have capital order and capital ordering. And when order is one of these P functions, but ordering is not. So I think it's a bit confusing when we say ordering function, because ordering, capital ordering, is not one of them.
Oh boy. So ordering is asking for the permutation, which is the ordering of this list.
Exactly.
Right? Okay, but so what's the question here? So I mean, we don't have a good name for the by function.
Exactly. The main question is the name for the by function, and then the other is somehow the question of whether in the documentation we should start moving from ordering function to order function.
I don't think so. Order function is I mean, yes, it might be more mathy, but I think it's totally confusing.
Okay. I do agree we have always called P ordering function.
Yeah, I think it's the right thing to do. I think it's common English usage. I think order function, it's like, you know, the word order is used in probably 25 different ways in mathematics, this being one of them.
I see.
And why confuse everything like that?
I see your point.
Here, I'm pulling down a copy of Ken Iverson's book from my shelf to see what he calls Serial sorting processes. Okay, he has a whole chapter on sorting. Here, I can put this on my document camera just for fun. Let's see. Works. Okay.
Mm-hmm.
Okay, just for fun, we can go look at what in the ancient times what was done. Yeah. I don't know what this is. This is okay, sorting. Yeah, I don't know. I mean, this is definitely, there's probably a version of this on the web somewhere, but anyway, I seem to remember that this exact issue comes up here, and I'm trying to remember whether there's a nice name. I mean, not all the APL names, like the APL notation, can be quite crazy.
Right.
And this is crazy as usual. I think this is not relevant here. All right, no matter. Not no, not relevant. This is a discussion of how to do various kinds of sorts, which is not what we're talking about here. Anyway, it's always fun when this actually turns out to have something relevant in it. Oh yeah, ranking. That's right. I mean, that's the yeah. Anyway, I mean, because that is what that is. That mathematically, it's some kind of ranking function. I think. We're describing the unary case.
Yes, what we call ordering.
No, what we call the unary by functions define. I mean, in other words, you say this is the rank of that thing, and then you sort it by rank, so to speak, as opposed to a binary comparator function. I mean, really, our P functions are comparator functions.
Yes.
I think what these really are comparison and ranking functions, probably. But that's not what we're describing them as. I mean, we could start describing that P function as a comparison function.
Yes.
It would be more accurate to say that than to say an ordering function. And then the other one would be a ranking function, I believe. Well, those are two possible names. Whether we want to start changing to use that, I'm not sure. Let's take a look at what the actual issues are here.
Well, we have added the ordering or comparison function to key sort. So we have featureized nodes, and I think we should approve them.
Seems reasonable to me to have a comparison function there.
Yes.
You know, comparison function is the right name for this. I don't know what we call it in sort right now. Let's take a look. Yeah, I mean, arguably that should be comparison function. I'm not sure. Anybody else want to comment on this? See, this is confusing because these are the return values. This is the comparison. True, false.
Yes, so So ordering or comparison functions can be of two types, the Boolean ones and the numeric ones.
Mm-hmm.
And the system supports both simultaneously.
Yes.
So those that return 0 are more useful in identifying ties, because in a sense, true, false, you need to evaluate them in both orders to realize this is a tie.
Oh, that's terrible, yeah. Right. So what do we call that in the order defined by applying? Okay.
Yes.
But that has another level, right? It's got to, if F returns something which itself is non-trivial to sort, how do we deal with that? Do you see what I'm saying?
Well,
so let's say the sort by returns pairs. We've still got to figure out how to order the pairs.
Yes, and that's why we are working on adding a third argument to sort by with an ordering function, which has always been missing. And it's important. It's an important thing to have a function which will be sort by, which handles simultaneously both types F and P functions.
I'm sorry, what are you saying?
Yes. So what you were saying is that what happens if sort by returns F values that must be sorted?
Yes, that's correct.
Yes. So the solution to that is adding a P argument to sort by. And
Do we
Danny
have that argument?
We don't have it yet, but Danny will add that.
Okay, so the plan is a third argument for sort by. Is that
exactly.
correct?
Exactly.
Yes.
Yeah. And that will make sort by the most powerful function in the sorting area, because it can handle both at the same time. And
yes.
this is needed in applications like, for example, sorting a bunch of vectors by norm.
Right.
This will do it always via canonical order, while typically we need it via.
I'm having a tremendous deja vu here. This is, let me look at something. I'm curious whether this is, let me just see here. I have a very bad feeling about this. That this is my deja vu is, I think in SMP it had a sorting function that had exactly this by two thing, and I wonder what they were called. Let me see. It's kind of depressing. This is like 38 years ago or something. There we go. Sort. What do you know? There it is. Look. This is, okay, so what this did yields a list by sorting top level entries so that either, what?
Well,
okay, so this had the notion of a cardinal, and I knew I remembered this from somewhere, of a cardinal and an ordinal sorting criterion.
I see. So
and in fact, this is exactly our sort by.
Right. Yes, we were discussing whether to add the two arguments in sort or in sort by, and it seemed more useful.
I think sort by is a better place to add them.
Right. Yeah.
And this is a weird case here, look, of doing a sort. Yeah, I mean, SMP, for its sins, did not have a good pure function mechanism.
I see.
Okay. I knew I'd seen this before.
Right.
38 years ago or something. Okay.
Yeah, so that's an example of how we can use key sort with alphabetic orders.
Looks good to me.
Or we could use numerical orders, etc.
Yep, looks good. Should we move on?
Yes. Well, do you want to unfeatureize the notes in the page, or should we do it?
I can trust you to do that.
Okay.
I think.
Mm-hmm. Okay, so then we are working on reverse sort by, and here there is a small issue, but we wanted you to be aware of it, which is that when it comes to ties, sort and sort by do something slightly different. And now that we are introducing reverse sort and reverse sort by, we need to decide which one to follow.
Oh boy. Okay.
It's a small thing, but just for you to know.
All right. Okay. So what is happening here? So sort. What does sort and sort by do for ties?
Exactly. So when sort finds a tie, it will use stable order. So it will leave things as they are. While sort by will go and use canonical order on them. So that's why, even though this...
Explain to me, why is there that difference?
Because sort says, oh, by numerical order, these two things are the same. So I'm going to leave them as they are. It could have said, oh, I'm going to use canonical order now, because there was a tie.
I see. Whereas sort by is using canonical ordering of the ranking function. Is that correct?
Of the original things before applying n.
Oh, so if the ranking...
Exactly. If the ranking is not able to decide,
yes,
because it gives the same results, then it uses canonical order.
Why?
Because it's how it works.
No, but I mean, why do we make it work that way rather than leaving it in the same order as it came in as?
I don't know. This has been always that way.
Anybody know the answer to why that was done that way? I mean, I don't know why it was done that way.
I do not. I just have vague recollections of email about it from involving, I can't even remember who.
Right. So this is the thing, that it has this list of functions. So if we wrap n in a list, then it will do the opposite thing.
So if some of the FE are the same, then the canonical order of the corresponding E sub I are used.
Exactly. Yeah.
But it then has this multi-criterion mechanism.
Exactly. Which lets you decide what to do in case there are ties.
So you're saying if there's a singleton list here of F, what does it do?
Because there is no other F, it uses stable order. So if you run that example on your left with n wrapped in a list, it will do the opposite.
I think one reason...
Sorry, I didn't understand that. Why did that happen?
It uses a different convention with the list and without the list.
Okay. Danny, what were you going to say? One reason, ...
Sorry, I was on mute. Actually, what I was going to say, I think was incorrect. So I'll hold off until I correct it.
Okay, so let's look at reverse sort then.
Yes, so reverse sort follows sort. And
so wait a minute, does it do the reverse? It doesn't do the reverse.
It uses stable order as well.
So in other words, it leaves it the same if it is a tie.
Exactly.
Yes.
And it seems reasonable that reverse sort does whatever sort does. Now, the problem is that reverse sort by cannot follow simultaneously reverse sort and sort by. And that's our conflict.
I think it should follow sort by.
That's what we have.
That's what we have right now.
Yeah, I think so. Seems reasonable to me.
Mm-hmm. Yeah, so then we have that identity there. For F without a list.
I agree.
Mm-hmm. Okay, so another one we have added, which we have to write a ref page for it, is ordering by, which has these 4 arguments now.
Oh my gosh. Okay. And what is ordering by? Does it have any ref page?
Not yet. Ordering.
Okay, so but which arguments does it need to have? So ordering by minimally has 2 arguments, right?
Exactly. It tries to follow ordering, which has 3. So ordering by has 1 more.
And what are the 3 arguments of ordering?
It's the list, the number of results, and the ordering function.
The comparator function.
The comparison function, yeah.
So somewhat bizarrely, ordering by has a ranking function, and not next to it is the comparison function. Yeah, I think it has to be that way, unfortunately.
Yes, Danny and I discussed that quite a lot because there are several precedents, and this is the one that followed all of them. But yes, it has F and P separate because F is compulsory, while the other two are not.
Looks okay to me.
Mm-hmm.
Oh gosh, how many functions do we need here?
Well, this one we don't have yet, and I just wanted to check whether it's worth having, because we are in all these bytes. This one it's kind of a gap now.
It's going to be very confusing to have that name. You talking order by?
Yeah, I don't think it's hopeless. I think it's hopeless.
Mm-hmm.
I mean, if you don't like it, just say order of f of x, f of y.
Right. So this is one of these functions that can be used in examples and relations to explain from the point of view of one function what the other does. It's kind of a link, but these definitions I wrote there can be added in examples, and then people would understand. So.
I think that's fine.
Mm-hmm.
All right. So ordering by, can you guys make some documentation for it? I don't think we want
it's on my to-do list.
Okay.
Mm-hmm. Okay.
All right.
So yeah, so that's the. We went quite fast today.
Right. Surprising. Okay. Okay. While we're at it, let's just have a little look at the longer list.
Yeah.
Who has this whole semantic cases business? I don't think that's for this meeting.
Yeah,
that's for the machine learning.
Machine learning, yes. We discussed that there.
Okay, fine. Let's see what I have down on this list here. Delete outliers. That's again a machine learning discussion. Is that true?
Yep.
Array association. What's happened to that?
Yes, that's with me. That's something I need to discuss. It's very related to data sets. So I'm waiting for Xavier to continue working data set.
Has he been heard from?
Yes. I'm having a meeting with him later today.
Okay, great.
Mm-hmm.
Okay, so but this idea of array association, of given a collection of keys in an array,
mm-hmm.
basically, I mean, I think array association. I mean, the name array association, at least I remember what it was when I saw it here.
So the basic idea from Tony is an alternative way of representing a nested list of associations.
No. No, what this is given an array, okay?
Mm-hmm.
Like you just got in a spreadsheet, but
mm-hmm.
you want to label the rows by one set of keys, the columns by another set of keys. This turns your plain array into a nested association, collection nested association.
Yes. I see what you mean. Yes, I was thinking of the other one, the association array. Yeah, sorry.
Wait a minute. What is association array as compared to array association?
Yes. So this discussion came from a suggestion from Tony that we could have an alternative way of representing that nested list of association. Because the problem with the nested list of associations is that it needs to replicate again and again the names of the.
I understand. Yeah, I understand. I mean, I don't know what we do actually in memory. I'm not sure whether we're doing that. Do we have a packed representation of this? Probably not.
No, I don't think so.
And that maybe is the right thing to be looking at, is a packed representation where we don't have to reproduce those things.
Right, exactly. So that's an idea to implement at least part of data set using that, avoiding.
Okay, but I've got a better, what I think is a better suggestion, which is we just haven't worked on making, we've got the correspondence between data set and external databases coming along. But I think a different issue is just like we have packed arrays, why not have packed association arrays, so to speak? See what I'm saying?
Yeah.
I think that's the right way to go. And I think it would actually be possible, conceivable at least, that we could use some of the packed array apparatus to implement some of that stuff.
Mm-hmm.
I mean, that's a completely different group of people. That would be Rob and people like that.
Yes. Yes, it's some sort of multidimensional association concept.
Yes, exactly. But which we already have. I mean, for packed arrays, we have multidimensional packed arrays. We just don't happen to have multidimensional association labeled packed arrays. I think that's the right thing. And that I agree that that's a gap. Okay, does anybody know what's happened to find character encoding? Sushma, do you know?
Yeah, he will work on it for version 12. He's working on it for version 12.
Yihei? Okay, but I mean, do we know if it's converging, and what meeting is that going to get reviewed in?
ILD. Yeah, whenever she's ready, I will bring it up in ILD.
Okay. What happened to column map and that whole family?
I'm still thinking about it, and I'm still concerned about having to introduce very many functions. So it would be better if we find some sort of nice notation that we can place in the third argument of map, for example, something like that. Perhaps you can. Perhaps we can discuss it again in some other meeting.
Okay.
Just that.
I mean, I kind of feel like column map and so on. It's a thing one's ended up using a zillion times, and it seems like it's an easy to understand thing. And even if it's a synonym for something that has a more structured form inside map, it seems like a reasonable thing to me. I mean, clearly it is. As it says there, map at f all comma 2, right?
Yes. So the worry is not so much about column map, but about having to introduce column insert, column delete, column extract, column, etc. I mean, if it was just column map.
Well, I mean, these things, they're used so often in, I mean, two-dimensional arrays. Look, the question is, how special is 2 dimensions? And if the answer is it's fairly special, then we should have these. And I think it is fairly special. I mean, I think people, we have a bunch of functions that operate on one-dimensional arrays in a special way, like insert, for example. So the question is really, I mean, here's the real basic question. Okay, first question, what is the analog of insert in n dimensions?
Insert, well, we can insert at any position or any list of positions.
So you're saying if I have a 4-dimensional array, that if I want to introduce a new slab, so to speak, into the 4-dimensional array, for instance, a new 2-dimensional subspace into the 4-dimensional array, so to speak, that I can do that by defining, but then in my insert, I have to actually give the coordinates of every element in that slab, don't I?
Yes, and the result perhaps will be ragged now, but the actual action is possible.
Okay, but by explicitly giving, it's not by giving it's by giving every individual sort of element in the slab. It's not by specifying the slab as a whole.
Both things could be done because you can insert a slab, say at level 2 in a 4-dimensional array. So we are inserting many of them at the same time.
Okay, how do you do that? So you say, let's imagine that I have a 4-dimensional array. So let's say I have a array 3, 3, 3. Let's just do 3-dimensional, okay?
Yeah.
Okay, so there's my array.
Yeah.
Okay, so now I want to insert something at what position?
So we can insert, for example, another 3x3 matrix at position 1. And then we will have a 4x3x3 result. So you can have that.
Array. Okay.
Yeah,
so
the array. Yeah.
And then what?
And now I never remember whether it's position object or object position.
Isn't that embarrassing? It's
element position. Object position. So now right there a 3x3 matrix. And at position 1.
like that.
Yeah. So
Okay,
now,
that was easy enough. So that was an insert at the top level. Okay, so now I want to insert it at a second level. How do I do that?
at the second level, you will have to insert a vector, for example. So specify insert.
No, but I've got this matrix. So how do I insert that? See what I'm trying to do? I'm trying to say, I don't even know how to think about this.
I see what you mean. I see what you mean. Yes. So in order to insert a matrix at the second level, we would have to insert 4 vectors.
Yes.
Or 3 vectors at the corresponding positions. Yes.
So, okay. So the challenge here is, can we invent a version of insert that would specify that what I want to do, for example, if let's say I want to insert a new column, quotes column into every one of these, right?
Yeah. Mm-hmm. Well, we have already the same problem with a matrix. How do we insert a vector in a matrix? Because it's easy to insert a row, but not so easy to insert a vector.
Because insert is a level 1 creature.
Right, I see.
Column would be a level 2 creature. The question is, what is the generalization of that?
I see.
And I think the generalization is that what you're effectively doing is you're inserting at a certain, like something like this would be the 3 column in, I mean, talking about this in a, if this is dimension 1, dimension 2, dimension 3, okay?
Mm-hmm. Yep.
So this is saying the 5th 3 column, so to speak. 3 column meaning the dimension 3 analog of a column.
Yep. Yes, indeed. I don't know whether that works actually, but the notation should be consistent. We could insert the array in your input 20 at all comma 3 or all comma 1.
I don't think this is going to work, but we can try it.
Mm-hmm.
No. Right. So I think this is the challenge here. Is can we generalize? And it's a reasonable challenge. Mm-hmm. Actually, I think our friend Ken Iverson and APL did something like this. They called them axes. Mm-hmm. I think they were incomprehensible to most people. But I think that they had a notion of this kind of thing, of how do you sort of operate on an axis, so to speak.
Right.
So really what this is a level spec, something like a level spec. Well, there are 2 things here. There's a level and there's a where are you in that level kind of thing.
Right. So the third argument of insert, like the delete or extract or replace part, are position specs. And this is something else we discussed in another ILD meeting. We need some sort of symbolic notation for the position specs. One of them being column. And then
right.
So that's the idea that perhaps by having this column, we can have these functions already acting on columns without having to introduce column dedicated functions, or at least all of them.
Right. Perhaps someone from the live stream is pointing out tensor surgery functions in neural net frameworks: expand, dims, and stack. Don't know exactly what those are. Presumably our neural net folk would understand that. And that is a good question with respect to these things, is how this relates to the tensor surgery that one wants to do for neural nets. I mean, we may already find out that many of our layer functions in neural nets actually do precisely some of this kind of surgery.
It could be.
So, I mean, let's just take a look, just as an example. Things like, I wonder what this does. Reinterprets the input to be an array of that dimension. Okay, so reshapes. So
I think this is the equivalent of array reshape.
Yes. I mean, the idea is that these layers, and by the way, that's you weren't involved, but that's a big design question, is whether we're going to de-experimentalize all these layers, whether we're going to commit to all of these layers. Humph. Well, I think, okay, so what this has turned into is a more general discussion about effectively array surgery.
Right.
Which I think is a great topic. So, I mean, the question is, what's the analog? What's the multidimensional analog of all these things? Okay. Okay, these operations, apparently, I'm going to paste from our chat here, the comment made. So one of these operations takes this and inserts a level. I think we have a way to do that.
We can map list to do that.
Right. And another is a reduction operation. No, is a pairing operation that takes, okay, that's yet a separate thing, which is related to array flatten. Is that right?
Yes, this is like matrices by blocks and things like that.
Yeah, so this is taking an outermost operation, binary operation here, and threading that through down into the lowest leaves of the object.
Yes, I think we have joined at a given level, and the way I would do this is just by wrapping a list around those and then a transposition.
Yeah. But, I mean, look, the basic meta point here is there is potentially effectively a calculus of a calculus of array operations that might be worth us looking at, because we haven't really, I mean, the world of neural nets. Okay, so look, 2 points to make. The column business, we kind of have known we need for a while. It's been in a standard package for 25 years. It's something one uses all the time. The case of higher dimensional arrays is somewhat a new phenomenon. I mean, people have been interested in that in the neural net world. Then, the question really is that a thing people really want to do, or is that a thing that's deep down in the weeds and done, one only does it once, and it's not something for which we need a general consumerized thing? I tend to think that it is useful to be able to take, I mean, a very common case is, well, not very, a common case is you've got a bunch of matrices, you happen to make a list of those matrices, you want to do some operation on the matrices, which you could perfectly well do on 2 individual matrices, but you want to immediately do it within these lists, but then we have map thread to do that.
Yes.
I mean, part of this might be you want to get from here to there, what functions you're going to use to do it. And that's more a user assistance question than it is necessarily we don't have the functions question. Unless there's a refactoring of our functions that would make it easier to understand what's going on.
Well, we do have most of the operations. Some of them are a bit complicated. I remember when I was working on quantity array, there was this concept of threading the deepest levels. So our threading function threads through the most external levels.
Yeah, I understand. Well, that's what this operation that we were talking about just now, the thing which takes an operation that is at the top level, big matrix, combined with big matrix, or big array, big tensor combined with big tensor, and then takes that operation and works it down to the leaves, so to speak. Yeah. All right. I think this is something we could have a useful meeting about. I mean, I wish I had a real direction for how to think about this. I mean, I think the first question is, what are some cases? And we know the column map and so on, things are an example of that. That's a case where, it's a very common operation. And the question is, so that's a unary common operation, right? Column map, etc., is something where you're taking the tensor and you're, applying some function to something. Okay, so a binary case would be you've taken two tensors, and back in the day there was inner and there was outer, and those were the things people cared about.
Mm-hmm.
So at a meta level, when it comes to like the neural net business, why is it that people now care about? I mean, because those were from a mathematical point of view, matrices as matrices and so on, or in general tensors. Well, okay, so inner, and now we're going to go general relativity for a moment. I mean, we have tensor indices and we have contractions of tensor indices.
Mm-hmm.
And that's what inner is kind of the special case of a product of tensors with contractions. Yeah.
Yes. The restriction there is that it takes only two, and it contracts only one index of each one.
Right. But in general, we have tensor contract that does arbitrary, that given a single tensor does. Now, I mean, I have no idea whether we've really thought through. Okay, so yeah, go ahead.
So tensor contract generalizes inner in the sense that it can do multiple contractions at the same time. And if we have a tensor product in the first argument, it will handle several objects. Now, the thing that doesn't have tensor contract with respect to inner is the ability of specifying the f and g functions.
Yeah.
Because tensor contract is fully dedicated to the algebra case. It's the same relation between tensor product and outer. Outer specifies the f function, while tensor product doesn't.
Why doesn't tensor contract allow an f and a g function?
It's just a matter of design. It was designed for the purely mathematical linear algebra case.
It probably should have an f and a g function.
We could add them in additional arguments, yes.
Right. I mean, similar to the way distribute is primarily designed for the algebraic case, but it can have arbitrary functions in it too.
Yes, that's correct. That's correct.
So tensor contract, if I'm not mistaken, can do, I mean, a question, and actually it's a good question for the neural net folk, whether tensor contract is relevant for them. And whether it in fact does some of the things that some of the layer operations do. But okay, but I mean, so at a meta level, one class of operations on tensors is contraction.
Yes.
In the world of neural nets, there may be some new operations on tensors that people start caring about. I mean, contraction is very much a creature of the kind of linearity, tensors as some kind of linear operator type things, isn't that right? I mean,
indeed. For example, another restriction in tensor contract is that contractions are always of two indices. We could think of contractions of multiple indices,
right?
Which is a concept that doesn't have a meaning in linear algebra.
Right, where effectively you're just feeding those indices into some arbitrary f function.
Right.
What is the most general form of tensor? So the most general form of how does so there's transpose, mm-hmm. which again can take two. Transpose is moving around indices.
Mm-hmm.
Contract is taking indices and doing reduction across those indices.
Correct. Yes. So the three fundamental operations with arrays, in terms of which you can write most of the other ones, or all of the other ones in linear algebra, are outer products, contractions, and transpositions. But then if we go out of linear algebra, we have more operations like array reshaping. That never happens in linear algebra, because in linear algebra dimensions are always preserved.
Yes.
So there are a few more operations that do not have a direct linear algebra meaning, but they are operations on general arrays.
Seems to me we should explore this.
Yeah, so the fully general linear algebra case I have under control, and I have some functions there in internal contexts which generalize the concept of array contraction. We can discuss about that.
All right, let's try to get, I was not expecting this particular spin-off meeting, but let's try to get a meeting with you guys, probably with, I mean, I think Rob is relevant to this stuff also, and with the neural net folk,
Okay.
to talk about general array operations and see, and the main result there is I want to determine whether we're actually going to put in column map and so on. My guess is that the answer will be that we will want to do that, but that it will be a special case of some things. And, you know, the suggestion then is that there may be some more general array operations that could be the master array operations that we need. And then we need to understand how those relate to the neural net layers and the particular operations like the flattening layers and catenation layers and so on, and whether there is a much more general way to represent that stuff, which may or may not, again, be something we actually want to, you know, it may still be very useful to have the layers exactly as we've set them out, because that's something you can easily read, so to speak, and not the most general case. All right, we should wrap here. Okay, we got through our agenda, which is good. Thanks, everybody. Thanks to folks on the live stream. Lots of great suggestions here. Talk to you all soon.
Bye.
Bye.
See you. Bye.